Hey guys, this is Miss Adams, and we're going to be looking at our Algebra 1 midterm review for the 2022-2023 school year. And I'm going to be breaking down this review by unit. So this video is going to be focused on our Unit 1 material. This was our pre-algebraic material dealing with our operations with algebraic expressions. So these first two problems, I'm solving for the variable x. And in order to do so, I need to first isolate my variable term. So number one says 3x plus 4 is equal to 10. And I've got to get that 3x by itself. So I'm going to use the inverse operation of addition. And that's going to be subtracting 4 on each side. Because whatever you do to one side, you got to do to both sides. That's going to leave me with 3x is equal to 6. And my last step, I need to, instead of multiplying that x by 3, I need to do the opposite of it. So I'm going to divide both sides by 3. Which leads me with x is equal to 2. And that is our solution for x. Now, number two, we can go about it two different ways. We can start off with a distributive property, or we can start off with division. I'm going to show you both ways. So if I was starting off with a distributive property, I would distribute the 2 to everything inside the parentheses. So that's going to give me 2x plus 6 is equal to 12. Then I would subtract a 6 from both sides. And that will leave me with 2x is equal to 6. And my last step will be to divide by 2, leaving me with x is equal to 3. Or, we're going to see if this matches on both of these. I could say 2 times x plus 3 is equal to 12 again. So that's that same equation that I'm starting off with. And now, instead of distributing that 2, I know that whole left side is multiplied by 2, so I'm going to do the inverse operation and divide both sides by 2. That's going to leave me with x plus 3 is equal to 6. Last step is to subtract 3 on both sides, which also leaves me with x equals 3. So it doesn't matter which way I solve it, I'm going to get x equals 3 both times. Now, for problem 3, we're going to be combining polynomial expressions using different operations. So this first one should be the simplest form, and that's combining these using addition. So I've got 4x squared minus 2x plus 1 plus x cubed plus 5x minus 4. Our goal here is to not only combine like terms, but to make sure that we write our simplified expression in standard form. Standard form being the greatest exponential value to the least exponential value. So, if I'm looking at this, my greatest exponential value will be the term x cubed, and there are no other cube terms, so I can go on to my x squareds. So in this case, I've got a 4x squared. There's no other squared terms, which means I can now go on to just my x terms, but in this case, I've got a negative 2x plus 5x. So negative 2x plus 5x is going to simplify to positive 3x. And last but not least, we've got our constants 1 minus 4, and 1 minus 4 is going to give us the value of negative 3. So I've taken both of these polynomial expressions, combined them into one 4-term polynomial expression. For number 2, we're going to have to do a little bit more with number 2, because I've got negative 3x squared plus 4x minus 5. But now I'm subtracting 7x cubed plus 4x squared plus 10. I want to do the opposite of subtracting, which is addition, because subtraction can just get messy. You can lose that subtraction sign. Easiest way to do so is, in order to convert from subtraction to addition, I need to change all of the signs in that second polynomial expression. So instead of a positive 7x cubed, I'm going to have negative 7x cubed, negative 4x squared, and a negative 10. Now we can combine like terms. So my first highest term is going to be that negative 7x cubed. There are no other cube terms, so I'm going to cancel out that term now. Then I'm going to combine my x squareds. I've got negative 3x squared and a negative 4x squared to give me negative 7x squared. And I can cancel out those terms. I'm now going to look at my x values. And in this case, I just have that 4x, so I'm going to add 4x. And Our last values are going to be our constants. I've got a -5 and a -10. That's going to give me a -15. So once again, we took these polynomial expressions and combined them into a 4-term singular polynomial expression. We're still going to be doing operations with polynomial expressions, but now we're going to apply it to some real life situations. In this case, I'm asking you to find the area of a rectangle. So it tells me the length of a rectangle is x plus 5 and the width is 2x minus 4. We're going to determine the area of the rectangle. Well, I know that area is equal to length times width. And we want to write this answer in its simplest form. So I'm going to do the box method because I know I've got to take a binomial, which is a 2-term polynomial, and multiply it by another 2-term polynomial. So I've got the polynomial for the length as x plus 5. As long as I keep that together, it doesn't matter if I write it on the top or if I write it on the left-hand side. And then I've got my width as 2x minus 4. So I'm just keeping that group together. And now comes the multiplication process. I know that 2x times x is 2x squared. 2x times 5 is 10x. X times -4 is -4x. And -4 times 5 is -20. But I do have a few things that can combine. I got this 10x and the -4x. 10x minus 4x is going to give me a 6x. So my simplest form here is going to be 2x squared plus 6x minus 20. All right, that leads us into now identifying these characteristics of polynomial expressions. So let's look at this first one. It says go ahead and write these out in standard form, which is what we've been doing, except now we may or may not have terms that combined. So the standard form of -4x to the 4th power minus 6x plus 2x squared. I'm going to start off with -4x to the 4th power because that has my highest exponential value. Then I've got plus 2x squared minus 6x. There are 1, 2, 3 terms here. My degree is going to be 4 because that's my highest exponential value. And my leading coefficient is going to be -4 because that's the coefficient on my highest degree term, which in this case is that -4x to the 4th power term. My coefficient on the x term is -6. And then it asks me for my constant. Well, in this case, I don't have a constant, so I can put that my constant is 0 because it's not expressed in this polynomial expression. For number 6, I've got m squared plus 2 minus 5m cubed plus m. So I've got to start off with that -5m cubed because it has my highest order, my highest number exponential value. Then I've got plus m squared plus m plus 2. There are 1, 2, 3, 4 terms, and we have a degree of 3. Our leading coefficient is -5 because that's the coefficient on that m cubed term. Our coefficient on the m term is just 1 because we only have one of them, and our constant in this case is 2. From there, we went into dimensional analysis. So this is doing unit conversions. In order to do unit conversions properly, we want to start off with what's given to us. So it says find the number of hours in 2 years. So I was given 2 years, so I know that's where I'm going to start off. Now I can look at my unit conversions here. I know that 1 year is equivalent to 365 days. The reason I put that 1 year on the bottom is because I want to cancel out those units here. So I want year divided by year is going to give us just 1 unit. That's going to cancel out the years. But I'm not to hours yet. I know that 1 day is 24 hours. So my days have canceled out, and I'm left with my unit of hours. In my numerator, so on the top there, I've got 2 times 365 times 24. But my denominator is just 1 times 1, so anything divided or multiplied by 1 is going to stay itself. So in this case, 2 years is equivalent to 17,520 hours. For number 8, it says find the number of centimeters in 20 yards. So 20 yards is where I'm starting out. I know that 1 yard is equivalent to 3 feet. And my yards cancel out. I know that 1 foot is equivalent to 12 inches. So now my feet cancel out. But now I need to convert from inches to centimeters. So I know that 1 inch is 2.54 centimeters. So I've now canceled out my other units and I'm left in centimeters. My numerator again is at 20 times 3 times 12 times 2.54. My denominator in this case is 1 times 1 times 1. So I'm left with approximately, or exactly, 1,828.8 centimeters. So therefore 20 yards is equivalent to 1,828.8 centimeters. That's the first page of Unit 1, so let's go ahead and move on to the second page. Problem 9 says, what's the difference between an equation and an expression? Well, an equation is going to have an equal sign. An expression does not have an equal sign. An equation, you can solve for something. An expression, you're going to simplify. Problem 10, this is one of our proofs. So they've solved through the problems. You just got to tell them how they solved it. So if you're solving the following equation and writing a 2-column proof, determine the reasoning that should be in step 3. So they started off with 3x plus 6 is equal to 15, and that was given to them. Then they used the subtraction property of equality to get to 3x equals 9. And now they've got x equals 3, and the only way they could have gotten there is by using the division property of equality, or the division POE. What they're saying is they divided both sides by 3 to get to their solution of x equals 3. Now for problem 11, we're looking at literal equations. So this is dealing with the area equation. We've got area equals length times width, and it's asked us to solve for the variable w. Well, currently, w is being multiplied by L. The inverse operation of multiplication is division. So I'm going to divide both sides by L. That means that w is equal to a divided by L. For number 12, it says solve for the variable p. When given, t is equal to p divided by 2. The inverse operation of division is multiplication. So I'm going to multiply both sides by 2 now. And that's going to leave me with p is equal to 2t. Which gets us to our last problem, which was applications with these polynomial expressions and just understanding some of these applications. This one says that Miss Valadez just got a new phone and each month she pays 25 cents per minute and a startup cost of $50. Below is the expression for her monthly bill. F of m equals 0.25 m plus 50. What does the variable in the expression represent? Well, I know she pays 25 cents per minute, but I don't know how many minutes there actually are. So my variable is my unknown, which is going to be the number of minutes. Then it asks, what's the constant? And in this case, my constant is that 50. And that constant represents the startup costs. And lastly, it asks, what's the coefficient? In this case, my coefficient is 0.25. And I know that's how much she pays per minute. So that's the cost per minute. All right, guys, stay tuned for the Unit 2 material video coming up next.